here we are, day 2 on section 3.3, and as promised, we're going to focus on the proofs today. In the previous day of notes, we walked through 1. Today, we're going to read through 1 and then also try some of our own. So, this is a proof of the theorem. And so when it's proof of a theorem, sometimes they can get tricky because you can't use the theorems in the proof, and sometimes they can be a little bit harder. But this isn't too bad. Let's take a look at it. It says prove that if two lines are cut by a transversal, so the alternate interior angles are congruent, then the lines are parallel. So remember, we're proving the theorem that you want to use. So let's see how they went about doing that. So according to this picture, given the alternate interior angles are congruent, that would be angles 4 congruent to 5, okay, which they give us. Now, we can use the other things we know. So angle 1 would also be congruent to angle 4 because they're vertical angles. And then that gives us angle 1 congruent to 5 by the transitive property. Now, we can use the other converse properties, just not the alternate interior angle 1. And so then we can say that G is parallel to H because if corresponding angles, we would say it like this: corresponding angles congruent, then parallel lines. That's how we would write it. Okay, so little sneak peek. We are going to be using all those angle properties. All right, so let's take a look at this one. We are given, on the diagram, angle 1 is 53 degrees. I'm going to write those in. Angle 2 is 127 degrees. And so I like they put it all together, given. All right, so remember, we can use the given information and the diagram. So we can see by the diagram that angles 2 and angle 3 make a straight line. And so we know the sum of them is 180. So that is because when we see two angles, when we see two angles together, that adjacent angles that make a straight line, we know they're a linear pair. And linear pairs are supplementary, so we can say that. Okay, and so now notice this is the change. And so what we did, instead of this, we now have this because we made that substitution. So this would be, what did I just do? Let's move that. So this is substitution. And then let's see, how do we go from 3 to 4? Well, looks like we subtracted 127 from both sides. So that would be the subtraction property of equality. And then, well, guess what? If the measure of angle 3 is 53 degrees and the measure of angle 1 is 53 degrees, then they are congruent. And that is definition of congruency. Same measure means congruent and vice versa. And then if angle 3 and angle 1 are congruent, what relationship do those have? Well, they're corresponding angles. So if corresponding angles are congruent, that means then we have parallel lines. All right, so that's a really good example of a proof using parallel lines, angle relationships. Let's take a look at another example. Okay, so in this case, we're given parallel lines. L is parallel to M, which is marked on the diagram right here. And then angle 1 congruent to angle 2. So again, diagrams are important. I'm going to mark those right now. Okay, so given, I'm just going to write it down here. I like writing all my given information first, but it's okay. A lot of times proofs like to write it just when it's needed. All right, so we do need to use angle 3 somehow. Given that those L and M are parallel, we know that angle 3 would be congruent to angle 1 because they're corresponding angles. So this is parallel lines. Because we have parallel lines, we have corresponding angles congruent. So now they talk about 1 and 2. So if 3 is congruent to 1 and 2 is congruent to 1, then we know that 2 is congruent to 3 by transitive property. And then that makes A parallel to B, because now if these two, I'll darken them up here, are congruent, the angle relationship between lines A and B they are alternate exterior angles congruent, then parallel lines. Okay, this looks similar, doesn't it? It looks very similar, but our proof is going to be different here. Picture similar, proof different. Okay, so our statements and our reasons. Number 1, we have L parallel to M again, and angle 1 congruent to angle 2 again. But, well, I guess it is similar. It's similar, but it will be a little different. But you can use the last proof kind of as a guideline. So, given. Okay, so angle 1 congruent to angle 2. L is congruent to M, right? So these two are congruent. So if L is congruent to M, we could say that angle 1 is congruent to angle 3, because if you have parallel lines, then the corresponding angles are congruent. So I'm going to mark that. And now, if 1 is congruent to 3 and 1 is congruent to 2, that means angle 2 is congruent to angle 3 by transitive property. And then now if angles 2 and 3 are congruent, oops, that should have been a 3. If angle 2 is congruent to angle 3, with regard to lines A and B, they would be corresponding angles. So we can now say A is parallel to B, because if corresponding angles are congruent, then we have parallel lines. So very similar to the last proof, but different, corresponding instead of alternate exterior. All right, here's the last problem. Now remember, we learned that if we have a line and a point not on the line, there's exactly one line through that point that's parallel to the other line. And so we want to figure out the measure of angle 1. But right now, angle 1 is not a transversal of two parallel lines. There, we got this crooked transversal thing going on. So what we're going to do, this is what we have to do. We're going to draw a line through that point. Oops. There we go. Parallel to the other lines. So first of all, A is parallel to B. We've got that. And then, let me get the parallel looking things. So if that line is drawn so it's parallel to A and parallel to B, we also learned that transitive property, right? If we drew it in so it's parallel to A and A is already parallel to B, then it's parallel to B too. So now we've got parallel lines with, say, one transversal here. And so if that's 100 degrees, remember consecutive interior, that would make this part 80, just this part right there. So it's not all of angle 1, but like half of it or part of it. And then down here, if this is 40, then this piece right here would be 40 degrees because it's alternate interior. So now we know that angle 1 is going to be 80 plus 40, or 120 degrees. So when you have that situation, that's how you have to handle that problem, by drawing in that parallel line. And today we're just going to have some proofs to practice, but tomorrow there's going to be a worksheet where you'll get to practice more of these problems. Oops.